Okay, so we are still on research methods for this video, but we're moving away from experiments, which is what we've been looking up to now. And we're going to move on to correlations instead. Now, correlations tell you the relationship that exists between two variables. Now, correlations aren't actually an experimental method, they are actually a way to analyse data. So when you're looking at a research study, it could be that they've used a questionnaire as the method to actually collect information from people, but the analysis that they've actually used to carry it out is a correlation. So correlations come in two forms. A positive correlation is when, as one variable increases, the other variable increases as well. So for example, if you spend more time running on a treadmill, then the number of calories you'll burn in that time will increase. A negative correlation is as one variable increases, the other variable decreases. So for example, the older a chicken is, the fewer number of eggs it's going to produce. Now, if there's no relationship between the two variables, we would say that there's no correlation. Now, one important thing to remember when you're talking about correlations is that there is no such thing as a dependent and an independent variable. That is for experiments only. When you're talking about correlations, you're just talking about variable 1 and variable 2. So scattergraphs are the way that correlations are displayed graphically, and you should be familiar with this from GCSE. So a positive correlation, where one variable is plotted on the x-axis and the other on the y-axis, shows a line, as in this diagram, moving up towards the top right-hand corner, and the closer those points are to the line of best fit, the stronger that correlation is. So for example, if the amount of time spent running on the treadmill was on the x-axis, you would expect the number of calories burned, if plotted on the y-axis, to increase as the minutes increased on the x-axis. A negative correlation shows the other way. So if we had age of chicken along the bottom on the x-axis, then you would expect the number of eggs produced to decrease as the age of the chicken increased. And if you plot a graph and you get something that looks like this, that would suggest that there is no correlation between your two variables. Now, the correlation coefficient is a number which shows both the strength and the direction of the correlation. So you don't have to draw a graph in order to determine whether it's a positive or a negative correlation. You can do a calculation as well. You do not have to know how to do this calculation for your exam, but you do have to know what it means. So a correlation coefficient, the number will range from between -1 and +1. So -1 is a very, very strong negative correlation, and a +1 is a very, very strong positive correlation. If you get a correlation coefficient that comes out around 0, that would suggest that there's no correlation. So if we just look at this in relation to the three graphs that we were looking at earlier, the no correlation graph would sit in the middle because a correlation coefficient of 0 would suggest no correlation. Because that negative correlation is very close to the line of best fit, that would suggest that it's quite strong. The correlation coefficient in that case would probably be quite close to -1. And if we look at the final graph, that, as again, the points are quite close to the line of best fit, so I would imagine that the correlation coefficient of that graph would be somewhere near +1. So you can have a look at the notes in the pre-reading, re-look at this video if you need to, but before you come into the lesson, make sure that you can explain what we mean by a positive and a negative correlation, that you can interpret a scatter graph in terms of saying what the correlation is and whether it's strong or weak, and also explaining what a correlation coefficient tells you about the strength and direction of correlations.